Now we are going to do the problem. Suppose A, B, and C are positive integers that they add up to 2006. And if you take factorial of each one and multiply them, you get a whole bunch of zeros. Where m and n are integers and m is not divisible by 10. That means m will not sneak in 0 for you. Only this will produce 0. So there will be n zeros at the end. What's the smallest value of n? How could you distribute this A, B, and C such way that you get the least number of zeros when you do product of their factorials? How do we do this? Well, the thing is, A factorial gave you zeros, right? And B factorial gave you zeros. And C factorial gave you zeros, and you multiply them, you added them. So let's find out how many each one gave you, so that you can add, when you multiply these numbers that are ending in zeros, you will be adding the number of zeros, right? So let's find out. Okay, now, what are we dealing with? The 2006. Okay, 5 to the 4th is 625. 5 to the 5th is 30,000, right? So it's bigger than 2006. So we don't have to, we just got to go up to 4. That's just what I wanted to see. 625 times 5. 2 is 5. 2 went up. 6 is, what is it? 30. And this went up. That's what happened, right? So this exceeds 2006, so we don't need 5th power. We just need to have up to 4th power. So let's see how many zeros there are inside A factorial. Oh, that's A divided by 5 and do the integer part, and A divided by 25, do the integer part, and A divided by 1 to 5 and do the integer part. And it could go as high as 625 and do the integer part. That's how many it would have. Same thing with B, same thing with C. Okay? So that's how many zeros there will be, and we will be adding them. So how do we express this? Well, let me express this more elegantly. The first one could be expressed as summation of A divided by 5 to the k. Now we know k goes from 1 to 4. And truncation, right? Okay. What about this guy? Well, you know, we don't have to go through the whole thing. We know what's going to be. K1 through 4 of B and 5 to the k. That was easy. What about the third guy? The same thing. K. 1 through 4. C. 5 to k. Okay. All right. Now, but thing is, they have the same summation and same base and all. So why don't I add them? So what do they become? So I will put the same summation sign here. Let's see. So I will have summation of k going from 1 to 4 of A 5 to k. And we are taking the greatest integer. And B 5 to k, and we're taking the greatest integer. And C 5 to k with the greatest integer. Okay, then you may say, why don't you just combine them? We have the common denominator. Because they are greatest integer things. They could be losing something, and if you combine them before you take the greatest integer, there may be some monster growing inside. But we've seen this inequality before, right? But let's see, this is the total number of zeros here. I'm just counting how many zeros this guy had, how many zeros this guy had, how many zeros this guy had, and I'm adding those zeros because I'm multiplying these numbers. Then you may also say, well, this was 2006. Some of them could have been, you know, A could have been 2006, the other could have been, or A could have been 2000, and B and C were 3 and 3. And it's an injustice to divide by 125 like that. We don't care because the greatest integer function would nicely make them 0. So this is just safe. And in fact, I could have used some bigger number here too. But that would be just producing 0 no matter what. So that's just waste. So this number, do not worry about dividing too much because this greatest integer function takes care of it. Okay, now I need to combine this, but there may be growing like 0.999, 0.999 in here. So I cannot be reckless. So what I have to do is I have to use that inequality I showed you before. So this n, now it becomes inequality. N is less than what? Now you combine them. K goes from 1 through 4. And I now found the common denominator, 5 to the k. And it's still I'm chopping off all these extra decimals. And I'm adding a plus b plus c. But remember that minus 2 business comes in. Right? So that's how it becomes. Okay. Then what does it become? Well, you know what a plus b plus c is. It's 2006. So let's see what we get. K goes from 1 through 4. I have 2006 divided by 5 to the k power minus 2. Okay. Now, if you do here, of course, I still have this, right? Okay, now we got 4 terms here, and now we got to do the computation. So, shall we? We got to plug in 1. What do we get? 2006 divided by 5. Take the integer part only. And then, next one is 2006 divided by 25. Take the integer only. And 2006 divided by 1 to 5. Take integer only. And 2006 divided by 625. Take the integer only. And then this one got subtracted 4 times. So it's minus 8. Okay. So what do we get? This one is 401 dot dot dot. We don't care. We are chopping off the decimal part. And this one we are dividing. And we get 25 times 8 is 200. So 80. The decimal part we are ignoring nicely. It feels so good to ignore. When you do this, you get 16 and some decimals. We ignore. And here, 3 and something. We ignore. Minus 8. So therefore, this comes out to be 492. Okay. What did they want to know? What is the smallest value of n? Well, smallest value of n is 492. So that is the answer. Boy, this was a tough question.